All right, problem number 6. I want to sketch this function, but I want to do so without using my calculator. So if I want to do that, I'm going to do a little work. I'm going to write this function in two different forms. I'm going to convert it to vertex form so I can identify my vertex, and I'm also going to convert it into factored form so I can identify my x-intercepts, because it says label the vertex, the y-intercept, the x-intercepts, and one other point. So if I look at my function, y equals x squared plus 2x minus 3, if I want to write that in factored form, I got to play the number game to find two numbers that multiply to give me negative 3 and add to give me positive 2. So again, to do that, just list the factors of 3 and 2. Since my term 2 is positive, I need the bigger number to be positive. I wrote 3 and 2 there. I don't have any idea why I was talking about 2. But the factors of 3, all we got are 1 and 3. So it's got to be positive 3 and negative 1. So factored, we're looking at x minus 1 and x plus 3, which give us the zeros, x equals 1 and x equals negative 3. So I got my 2 points right there. I've got negative 3 comma 0, and I've also got 1 comma 0. 2 points down. To find the vertex, like I said, I can complete the square on this, and if I do that, I'll get y equals x plus 1, because I'm taking half of my x term there, my 2, half of that coefficient, squaring it. Then I have my minus 3, but when I square it, I'm going to be adding 1 to complete the square, so I have to subtract 1, so I'm going to get minus 4. And then again, looking at vertex form, we can identify our vertex by pulling out both of our terms to get the point negative 1 comma negative 4. So I got 2 points now. To find the y-intercept, all you got to do is set x equal to 0. So I'm going to get y equals 0 squared plus 2 times 0 minus 3, which is just going to be y equals negative 3, because both of those terms are going to cancel out. And that gives me the point, it gives me the point 0 comma negative 3. So I've got 4 points identified. I'm going to stop for a second and draw this in real quick. So if I want to draw my axes in, I'm just going to split it right down the middle, go straight down, and then I will go straight over as well. I'm going to start marking my points, and I'm going to change my pen color just so we can see it easily. So first points, I got my x-intercepts, negative 3 comma 0, so I'm going to go 1, 2, 3, that's that point right there, and I've got the point 1 comma 0 right there. Let's see, I've got my y-intercept 0 comma negative 3, so I'm down here. And finally, I've got my vertex at negative 1, negative 4, which is right there. Okay, and the reason that I did not yet draw in my last point, or talk about the 5th point that I'm going to find, because it says one additional point, is because I want to draw my axis of symmetry. Because one of the cool things about a quadratic function is that it has an axis of symmetry, which means since I have my axis of symmetry running right through the vertex right there, since I've gone to the right 1 and up 1 to get to that point from that point, I know that the other point, which I'll mark, has to be on there as well, because quadratic functions have symmetry, which is super cool. But I got my 5 points, so now I'm going to sketch this function in to the best of my ability, curve it, and shoot it on up. And we are done, and it looks super, super awesome.